All right, so last time we learned about the parts of an experimental design, completely randomized experimental design. And we're going to continue talking about that, but there's different situations that call for different things, and different things might be best. So today we're going to talk about blocking, and it has nothing to do with football. This is section 4.2b on blocking in experimental design. So here's the situation. Suppose that a mobile phone company is considering two different keyboard designs, let's just say A and B, for its new smartphone. The company decides to perform an experiment to compare the two keyboards using a group of 10 volunteers. Unfortunately, it's volunteers, so it's not a random sample, but we can keep going with it. The response variable is typing speed, measured in words per minute. So we're trying to figure out typing speed. Now, what actually is the best way to do this, since there's people who have cell phones already. So it's kind of not fair if they already know one of the designs. Like they're already familiar with it. Their things are going to be a lot faster. And what if they're all in the same group and it's just not accurate? So in this case, it says we know 4 of the volunteers already use a smartphone, whereas 6 do not. They can use a completely randomized design and hope that the random assignment distributes the smartphone users and non-smartphone users evenly. But even so, there might be a lot of variability in typing speed in both groups because some members are much more familiar with smartphones. This additional variability might make it difficult to detect a difference in the effectiveness of the two keyboards and might take away from the point of the experiment. So, what should they do? Well, because the phone company knows the experience with the smartphone will affect typing speed, they start by separating the volunteers into 2 groups right off the bat. One group are experienced smartphone users, and one of them are non-experienced smartphone users. So then within each group, they divvy up and do randomly assign keyboard A to keyboard B. So they're getting a mix from both. These are called blocks. And our blocking design is going to look very similar to our regular design. However, we're adding another layer. So this is the block part. This is not randomized. This is actually on purpose. We want to be able to explain why we're blocking. It's like we're taking the volunteers and we're divvying them up into 2 different groups, and then we're doing the whole randomized design. I'll put this in the randomized design and this into the randomized design. So if you look at it, it looks similar to what we've done in the last time, where each of these individually, you take the users that we have there, random assignment, give them keyboard A or keyboard B, so those are our 2 groups, and we compare their speeds. But what's different is that's coming from our original 10, and then we also want to compare the results between those 2 groups, combine those results to use our data. So blocking does create a little more work, but it might be essential to making this an accurate design. So, some terminology. A block is a group of experimental units that are known before the experiment to be similar in some way that is expected to affect the response to the treatments. These are kind of similar to strata when we're dealing with surveys. However, this is not surveys, so let's not get those mixed up. In a randomized block design, the random assignment of experimental units to treatments is carried out separately within each block. So using a randomized block design allows us to account for variation in the response that is due to the blocking variable, something that we know. So this makes it easier to determine if one treatment is really more effective than the other. Tip: please, please, please don't mix language. Don't use language that you're not essentially very confident on, and don't mix surveys and experiments because they are different. So examples here where it says, use a randomized block design to select the sample for the survey. That's combining block design and surveys. Those are different things. You will be docked on the AP exam for doing that. Or this experiment suffers from non-response. Experiment, not a survey, so we're not going to talk about non-response. Okay. So, experimental designs with blocks. A couple notes. Make sure you put your experimental units or subjects into blocks right away. That is not random. This is on purpose. to divide them up into a way that makes them common. And then explain why you're using that. So this is what we're going to be doing right away. And then within each block, we're going to random assign to groups and treatments, compare within each block, and then compare between the blocks. So there's two comparing going on. Okay? So I've got an example here. It says an expert on worker performance is interested in the effect of room temperature on the performance of tasks that require manual dexterity. So things using your hands for. She chooses temperatures of 70 degrees and 90 degrees Fahrenheit as treatments. The response variable is the number of correct insertions into or during a 30-minute period in a peg-in-a-hole apparatus that requires the use of both hands simultaneously. Each subject is trained on the apparatus and then asked to make as many insertions as possible in 30 minutes. So how many times can you get the peg in the hole? In 30 minutes. 20 subjects are available to participate in the experiment. Now, there's some things here that might make something different. Maybe age, because your hands don't work quite as well the older you get. Maybe gender. Usually females have much smaller hands than males. So because gender may impact the ability to perform tasks of manual dexterity, a randomized block design is appropriate. Explain and diagram/outline how you would conduct such an experiment. Okay? So, we are told to do it by gender. We want to explain that we're going to block by gender because I'm going to say hand size is generally different. Between genders. Causing differences in manual dexterity. All right. That's why we're doing this. Now, if I want to outline this and actually make a randomized block design, I can make a diagram again, or I can put it into paragraphs. It's totally up to you. I'm going to start by doing this design with a diagram. So I have 20 subjects. Didn't say much else about it, where they're coming from. These are just 20 subjects. Now, before I do any randomization, I need to decide what my blocks are. And I'm going to divide these up by males and females. We've got 10 of each. Now, within each of those groups, I want to now do a random assignment. Okay, you would have to explain your random assignment. You can explain it once and just say, do the same thing for males or females, whichever one you start with. Do it for one and just do the same for the other. And then we're going to divide them into groups. It looks like we're going to have 5 in each. But we're going to do the same thing with females. So maybe better with different colors, but I'm going to dividing those up as well. Those are my group 1 and 2 for each of those. N equals 5, N equals 5. Now, we're going to keep going. The treatments for this is going to be the 70 degrees Fahrenheit and the 90 degrees Fahrenheit. Same thing here. We got to do 70 for one group 90 for the other. And we want to compare. We're going to compare the number of insertions. But I'm going to do the exact same thing with both genders here. We're going to compare number of insertions. But we still have to look at one other thing. We want to compare both. So in the end, we're going to combine results to compare. Because we want to see between the males and females differences as well. So this is ultimately the process. What's different is we're starting it by dividing it up, and we're going to end up making more than one group. So I said block by gender because the impact may be different for manual dexterity. I have my explanation here. Random assignment, put all names of females into equal-sized slips of paper in a hat, mix them up without looking and without replacement. Select one at a time until half are drawn. These subjects go to group 1 and the rest go to group 2. Repeat for the male subjects. All right, so you can just say that. But we could have done a random number generator. We could have done a random number table as well. We could have said flip a coin. So if heads, group 1 gets... Oh, that's the other thing. So I didn't mention this before. We should be random assigning the treatments as well. Now, that is not absolutely essential, but it's good to decide which one goes to which. So if I flip a coin, because I have two options, if heads, group 1 gets the 70 degrees. If tails, group 1 gets the 90 degrees. So I'm making even more randomization here. So the more random, the better. Now, I want you to take a look at this example and see if you can answer this one on your own. Same sort of idea. I'd like you to pause and try it and think about the different parts that you would need for this one. All right. Looks like for this one, we are trying to, this is about surgical procedures to correct nearsightedness. So we were trying to measure subjects' glasses prescription. So form blocks based on how bad their vision is as a degree of nearsightedness, because some people don't have that bad of nearsightedness. So it might be an impact based on how they start. So we could do okay vision, medium vision, and poor vision. So we have 3 different blocks. Now in those 3 different blocks, maybe we say good, decent vision, medium vision, bad vision, something like that. But it's going to be different depending on how you start. So let's divide them into those 3 groups. And this is how I'm doing it without, I'm not doing the diagram, but you can do this written out in paragraph form or in bullet points. So assign each subject in the okay vision group a random number, or a number. Randomly generate unique numbers until half are selected. So if you don't know how many numbers there are, you can say it just like that. Until half are selected, these 2 subjects will get procedure A and the rest will get procedure B. Repeat for the other blocks. So explain why we're blocking and what we're blocking, and then how we're going to randomly assign them. Compare the change in vision for each vision block, and then combine the results and compare the change in vision between procedures A and B. Okay? That covers all the pieces. Maybe you like it better this way, that it's not in a diagram. Maybe you don't. But that's how we're going to do it by blocks. This first part explains the block and why we did it. Okay, this is the part that's different. And then we also need to say this as well. Now, in certain situations, there's so much variability in how subjects will respond to the treatment or with other variables. So in these situations, we need a specialized block design called matched pairs. So a specialized type of block design is matched pairs. It's a common form of blocking for comparing just 2 treatments. So in some matched pairs designs, each subject receives both treatments in a random order. Okay. In others, 2 very similar subjects are paired. and the 2 treatments are randomly assigned within each pair. So if there's a difference between 2 subject and 1 subject. 2 subject treatments, those 2 subjects have to be so similar, like they literally should be like twins, to be able to do it. Because we don't want there to be a bunch of variation for other things. So if you literally have like identical twins, that's perfect. So 2 subjects paired based on common characteristics that might affect the response variable. Okay, maybe you're checking plants and they're from the same pot. It's like they're twins. Same soil, same watering, everything like that. We could compare those 2. 1 subject from each pair is randomly assigned to each of the treatment groups. Okay? So let's just say the first one. That's assigned to one treatment group, the other one's assigned to the other. Now, 1 subject is also allowed. So in matched pairs, you can do 1 person or 1 thing, but it's going to be their own twin. And there's different ways you can do it. So 1 subject receives both the treatments. You either have to do it where there's no overlap, like maybe I'm testing something on one arm and then testing something else on the other arm. That could work. So that would be given simultaneously. Or they could be assigned in random order. And if they're not simultaneously, they're in a random order, there has to be some sort of a wash period, what it's called, between the treatments. So like you give one thing one day and then wait 24 hours, you give it the next day, see if there's a different reaction to them. So there's got to be some sort of wash period. We don't want to give it right after each other, otherwise it's hard to really tell the difference. So matched pairs, these are, again, another way to say what I just said, but your kind of options are put your subjects into pairs and explain how you're pairing them up if there's 2 people, or use single subject pairs within each pair, random assigned to groups or treatments, meaning like your arms, or random assign the order of the treatment, and then you have that wash period. Okay? So let's look at an example of when this might happen. So it says, Senora believes that when students make flashcards to study Spanish vocabulary, they will be more successful than students who simply read their notes to review. Describe how she can design an experiment in which a matched pairs design is used with 2 subject pairs. So we are going to use her Spanish students, but we want to come up with some sort of pairing. Now, something where they're similar and they probably have similar experiences, been through similar classes together, and maybe grades. Like those who have an A, those who have a B, those who have a C, because they're having similar success. That could work. You could do it based off of grade level. Maybe they have a similar set of skills. So explain one of those things. So here's how I would start my design. I'm going to bullet point this one. We're going to use Senora's Spanish students. And we're going to block. We're going to make this match pair. So I'm going to create 2 subject matched pairs. So within this, I'm going to explain how I did it. So we'll say pair students by, pair students by grade in Spanish class. I'm going to say because that might reflect different vocab knowledge. I definitely spelled that wrong. Vocab knowledge or skills. So I've got my matched pairs. Now, How am I going to actually carry it out? We'll say for each pair, assign, we'll do this one. Assign each student a number 1 to 2. Randomly generate one unique number one to 2. Put that student in group 1. And the other in group 2. Now, we'd have to repeat this for each of the remaining pairs. Let's say for remaining pairs. Now, group 1, study with flashcards. And group 2, we'll study with notes. Now, once we're done with all of that, by the way, if I don't want to generate a number 1 through 2, I can flip a coin, and I'll just say H is, so whichever one, H is the first student, going to go into group 1, and tails is the second group going to go into group 1, or second student is going to go into group 1. We just assign it heads and tails, and we'll say whichever one it is goes into group 1. Okay? So you can flip a coin. You could do names in a hat. Just put 2 names in a hat. Whichever one you pick goes into group 1. The other one goes to group 2. So you can explain how you want, but we want to finish it off by doing some comparing. We're going to find the difference in vocab scores. Between each pair. Because those pairs are similar in some way. And then compare the difference between all pairs / treatment groups, which would be flashcards or notes. All right? That's how we're going to break down this matched pairs design. It just adds another layer that hopefully will give us a more random design and help with our results, make them more accurate. The more we can do to get them accurate, the better. Okay? And we can look at different things as well. Like here it says Coach Seeley believes that students at Hamilton High School prefer Gatorade when it's chilled to 40 degrees as compared to when it's served at 50 degrees. Describe how you can design an experiment in which matched pairs design is used with one subject pairs. Well, I'd say you'd have to do one person. You'd have to give them, we'd randomly decide what they would get first. So if you're in group 1, you'd get the 40-degree one first. In group 2, you'd get the 50-degree one first. And then you'd wait 5 minutes, and then you'd flip, which they get second. And then you'd have to actually look for how they liked it. Ultimately, we'd end up comparing. Here's another one. Miss Allman believes that females can complete more bicep curls when they wear gloves while holding the dumbbells. Describe how she can design an experiment in which a matched pairs design is used with one subject pairs. So maybe you could use both arms, or you do it like one day and then you do it the next day. Tricky part with one subject pairs is they're either getting stronger or they're getting tireder. So, but we'll just say use single subject matched pairs, as there's so much variability in strength from person to person. That's really hard to match up, even if you have legitimate twins. But you'd randomly assign half of them to group 1 and the rest to group 2. Group 1 will wear gloves first and see how much they can lift. Wait a week, then repeat without gloves. Group 2 will do the opposite. Compare the difference in weights lifted with and without gloves. And again, in that randomly assigned, we would use one of those things that we've learned. Random number generator, names in a hat, flip a coin potentially. That works when you have 2 people. It is random. So the idea here is, do you know what a matched pairs design is and how that is different than just a regular block design, how we can use that? But ultimately today was talking about blocking. So there's regular blocking. There's also that matched pairs design where we can group them based on some super similarities between 2 people or one person just with a wash period, or in a different order. So that is blocking. That's section 4.2b. We'll see you next time.